Hey there everyone, this is the video for lesson 2.7. We're going to start off with just a little refresher about how to graph linear equations and inequalities. Back in lesson 2.3 when we talked about slope, we did some problems where we were given an ordered pair and a slope as you see on the screen, and we practiced graphing those types of problems. So we'll just review that quickly. I have the ordered pair -3, -1, so I'm going to start off by plotting my point to the left 3 and down 1. And for my slope, I'm going to move down 1 and to the right 5. And I'll do that one more time so that I have 3 points connected together to make my straight line. So before we move into the material of lesson 2.7, we're going to refresh our memory on how to graph equations when they are written in slope-intercept form, which is y equals mx plus b. We're going to talk about the same concept as we did in this first example here, where we're given a slope and a point. However, this time our equation, we will be given an equation, and we're going to have to either put it in slope-intercept form or work with the equation already in slope-intercept form. So let's just quickly review what it means to be in slope-intercept form. We have our equation here. Y equals mx plus b. Slope-intercept form means that the y variable is always by itself on one side of the equation. M, we know, stands for our slope, while b is going to stand for the y-intercept of our equation. Remember from earlier on in this chapter, a y-intercept always has the ordered pair of 0 and some y value. So for our next example, we have the equation y equals -3x plus 1. This equation is already in slope-intercept form since the y is already by itself. So the first thing that I want to do is I want to graph my y-intercept value. Okay, so I have a positive 1 as my b value, which means that my y-intercept is located at the ordered pair 0, 1, which is right here on my graph. From there, I'm going to look at my slope, which is -3 over 1, which tells me that to get the remaining points on my line, I'm going to start at my y-intercept. I'm going to move down 3 and to the right 1. And I'll do that one more time so that I have 3 points. Connect those together to make my not so straight line. In the next problem that you see, we've got the equation x minus 2y equals 12. This problem is not yet in slope-intercept form since we do not have y entirely by itself. So we're going to work right now to get y by itself so that I'm in slope-intercept form. First, I'm going to start by subtracting x from both sides of my equation so that I have -2y equals -x plus 12. Next, to get the y all by itself, I'm going to need to divide every term in my problem by -2. This will leave me with the equation y equals -x divided by -2 is going to turn positive, and that's the same as saying 1/2 x. 12 divided by -2 is going to leave me with a -6. So I now have an equation that is ready to be graphed. This is in slope-intercept form since y is all by itself. And again, we're going to start with our y-intercept, which is -6, and plot that on our graph. Again, remember our y-intercept, in this case, is the ordered pair 0, -6. From here, I could use my slope, which is a positive 1/2, so I'm going to move up 1 to the right 2, up 1 and to the right 2. Connect my points together. That's a much better straight line than last time. And there we go, graphing in slope-intercept form. So now that you remember how to graph in slope-intercept form, we can talk about lesson 2.7, which is how to graph linear inequalities. There's a few things that we'll need to review first that you may want to write down before we do some examples. Graphing linear inequalities. Here's a couple steps for you to remember. First thing you always want to do anytime you're graphing an equation is make sure that you rewrite that equation in slope-intercept form. Once that's done, you'll be able to graph your line. If you remember back from chapter 1, we talked about the difference between the less than, greater than symbol and the less than equal to, greater than equal to symbol when we were graphing on a number line. Now that we're graphing on a coordinate plane, we're going to be using solid lines when you see the less than equal to, greater than equal to symbol, and then dashed lines if we just see the less than or greater than symbol. Just like we did on our number line when we had to shade our number line for our solution region with inequalities, we're going to have to also shade our graph on our coordinate plane when we graph inequalities. So we're going to do that by testing the ordered pair 0, 0, and once we've done that test, we will finish by shading our graph. Once you've got all of the directions copied down into your notes, we're going to start with some examples. Our first problem that we have, y is less than or equal to negative 2x plus 3. In this equation, we're already in slope-intercept form, so we can begin by graphing right away. We have our y-intercept of 0, 3, which we can plot on our graph. We then have our slope, which is negative 2 over 1, which means I'm going to move down 2 and to the right 1. Before we connect our points together, we want to double check about our inequality sign. Our inequality sign is the less than equal to symbol, which means I'm free to connect my points together with a normal solid line. Not the best line. So next we need to shade our solution region. So what we're going to do is we are going to test a point that is not on our line. So typically we want to test the ordered pair 0, 0 as long as it isn't on the line that we graphed. And the reason why we test 0, 0 is because plugging in the values of 0 into any equation is going to make your algebraic work much simpler. So when I test 0, 0, we're testing an ordered pair. That means we're going to, in this original equation, plug 0 in for x and for y in the original problem that they have given to us. So that means I'm going to have 0 is less than or equal to negative 2 times 0 plus 3. And now I'll just solve my equation, which says that 0 is less than or equal to positive 3. The next thing that we want to decide for our solution region is if this equation, this inequality 0 is less than or equal to 3 is true or false. This statement is true. Anytime we end up with a true inequality after we have tested our ordered pair, we're going to shade our graph, and we are going to shade that graph, since it's true, on the side that includes the ordered pair 0, 0. So as best as I can on this computer screen, I am going to shade the left side of my solid line. What this tells me, the solid line tells me that any value that is on my blue line, or my formerly blue line, any value on my blue line is a solution to this inequality that we began with. It also tells me, now that I've tested 0, 0 and got a true answer, that any value that ends up in this yellow shaded region is also a solution to the inequality that I had been given. Here's example number 2, y is less than negative 3x minus 5. What I'd like you to do right now, pause the video, see if you can graph this inequality on your own, and we will check your answer tomorrow in class. Together, we're going to move on to example number 3, which we will do together. This example, 4x plus 2y is greater than or equal to 8, is not in slope-intercept form. So we're going to have to do a little work first before we can graph. Remember, we want to get the y by itself. So we're going to start off and subtract the 4x to the right side of my inequality and divide everything by 2 in order to get y totally by itself and in slope-intercept form, which leaves me with the equation y is greater than or equal to negative 2x plus 4. So I'm going to start off and graph with my y-intercept, always my starting point on my graph. So I'll get that on there at positive 4. And from here I can now focus on my slope by moving down 2 and to the right 1. I again have the greater than or equal to inequality symbol in my problem, which means that I am allowed to connect all of my points together using a solid line as opposed to a dashed line. Hopefully your lines are turning out much straighter on your graph paper than mine are. And next, we can't forget to shade our graph. So the next thing that we'll do is we will test our ordered pair 0, 0. Since 0, 0 is not on our graph, it is just to the left of the graph, we're allowed to test it. So when I test, I'm plugging 0 in for both my x and my y value. Oops. That means on the entire left side of my equation, I'm just going to get 0, which is greater than or equal to 8. This statement is false. So now that I have a false statement, when I go back to my graph, since my inequality was false, I'm not allowed to shade 0, 0. Okay? When you have a false statement, you cannot shade where you have plotted 0, 0 on your graph. We're going to shade on the opposite side. The reason why we're shading on the opposite side is because our statement was false. Since it was false, it means that 0, 0 is not part of our solution region, which means we cannot shade that point in. So I'm going to shade everything on the right side of my blue line or my boundary line. So any ordered pair that I pick in this yellow region or on my blue line, I would be able to plug in to my original equation and have a solution or get a true statement. When you guys test 0, 0, it's always best, as I did in this example, to go back to your original equation, the one that was given to you, in order to plug in your x and your y values, just in case you have made a mistake in solving this equation right here that I'm highlighting. In case you made a mistake in solving that when it was time to graph, always best to go back to the beginning when testing 0, 0. One more problem for you, which you should now stop the video and try this last example by yourself. 4x minus 3y is less than 2, and we will check that tomorrow in class. See you next time, guys.